Okay, today we're going to be talking about minimum sample size for proportions. We talked about minimum sample size for means just a few lessons ago. This is going to be very similar, but it's going to estimate the sample size needed again when we're given a proportion rather than a mean scenario. Here's our formula that we're going to use. The formula in the book, guys, the p hat and q hat does come before the z alpha over 2 over e squared. But remember, multiplication is commutative, so it really doesn't matter the order of this formula. You're multiplying all those values together. But I am going to, when I do the examples, put p hat, q hat first, and then times the z over e quantity squared. All right, we're going to go ahead and take a look at our first example. This one says a researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. We're finding the minimum sample size necessary. All right, so picking out the important information from the prompt. We want 95% confidence, so the z critical value that's associated with 95% is 1.96. Again, we would find this from the z chart, and since 95% would be in the center of the distribution, we would look up on the negative z chart the closest value to 0.025 in the middle. That's how we get that z value of 1.96. The next value given in the prompt is 40%, and that is the proportion who own a home computer. So that's p hat. I would probably say that this example is a little outdated. The next value, we want to be accurate within 2%. So that is our margin of error, or E. Okay, so if our p hat is 40%, 40% of people own a computer, that means 60% would not own a home computer. That would be the complement of p hat, so that would be q hat. Plugging those values into our formula, we have p hat is 0.4. We multiply that by q hat, 0.6. We multiply that by the z critical value over the error, 2%, which is 0.02 as a decimal, and then we square just that critical value divided by the error. All right, so if I go over to the calculator and calculate that, I'm going to do that 1.96 divided by the 0.02 first. I'm going to square that value and then multiply it by the p hat and the q hat. This is a minimum sample size question, so no matter what the decimal, we always round this up. So even though I'm getting 2,304.96, I want to round this up to the next whole number. So my minimum sample would have to be 2,305. I could always sample more than that, but again, that is the minimum sample size needed, 2,305. All right, taking a look at the next example. We have the same researcher wishes to estimate the proportion of executives who own a car phone. She wants to be 90% confident and be accurate within 5% of the true proportion. Find the minimum sample size necessary. All right, so 90% confident this time. So the z value that's associated with 90% is 1.645. Again, that would be 90% in the middle of the normal distribution. That leaves 10% for both tails, or 5% for the left tail. So I would scan the middle of that negative z chart to the closest number I could get to 0.05. It is an evenly split one, so 1.64 and 1.65 are both evenly split between 0.05. So I average those two together to get that 1.645. We want to be accurate within 5%. That's the amount of error. Notice that this one does not give us an estimation for p hat. When that happens, guys, we are just going to pick 50%. Okay, so assume they're evenly split. So that would make p hat and q hat 50% or 0.5. Again, we do that anytime the estimate for the proportion is unknown. All right, plugging those values into our formula, p hat is 0.5, q hat is 0.5. We're going to multiply that times the z value of 1.645 and divide it by the error, which is 5%, or as a decimal, 0.05. Remember, we square just that z over e quantity. All right, plugging that into the formula, let me clear all that out from the last example. We have 1.645 divided by 0.05. I'm going to square that value and then multiply by p hat and by q hat. All right, that gives me a minimum sample size of 270.6, but again, we always round these up to the next whole number, so at least 271 are to be sampled. All right, guys, go ahead and pause the video. Try this next example on your own. Repause the video or replay the video to see the answer. So this is the you try. All right, hopefully you paused the video and you worked this out. Here's the solution. The 95% confidence level gives us a z-value of 1.96. The error is 3%. And again, since we don't have an estimate for the proportion, we would use 50%. Plugging those values in, p hat is 0.5, q hat would also be 50% or 0.5. We multiply that by the 1.96, which is the critical value, divided by the error, 0.03, and we square just that quantity. Over here in the calculator, I calculated that and got 1067.1. Again, no matter what the decimal place, we always round up to the next whole number. So my minimum sample size needed is 1068, at least that many people. I could, again, always sample more if I wanted to. This concludes today's notes, guys. So go ahead and post any questions that you have in the discussion and try the classwork.